In last video we have calculate how to calculate interquartile range or percentile range is over there. We have calculate if we are to calculate the dispersion of the middle 50% of the data, then we have to calculate interquartile range, that is Q3 minus Q1 is over there. If we are to calculate the middle 80% dispersion of the data is over there, then we have to calculate percentile range, that is the formula for the percentile range is P90 minus P10 is over there. Similarly, in today's video we are going to learn a new one methods of the dispersion. Already we have discussed a one methods of dispersion, that is called range method is over there. Today we are going to discuss another one method, that is called quartile deviation method. In quartile deviation method, quartile deviation. In quartile deviation, to calculate the quartile deviation, we have to calculate Q3 minus Q1 divided by 2. Already we know what is Q1 and what is Q3 is over there. To calculate the quartile deviation, the very first we have to do the quartile division is equal to Q3 minus Q1 divided by 2, and the coefficient of quartile division, that is Q3 minus Q1 upon Q3 plus Q1. In percentage form, if required, then Q3 minus Q1 upon Q3 plus Q1 multiplied by 100. If in percentage form it required, then we will calculate this one. If we are to having the comparison between two series, then we can having the percentage form, that is called the relative methods of the dispersion is over there. The very first, the quartile division is the absolute measurement of the dispersion which are having the unit, but the coefficient of the quartile division which haven't any unit is over there, that is called the relative measurement of the dispersion. Already we know how to calculate Q1 or how to calculate Q3. Already we have gone through with the in chapter first, that is called measurement of the center tendency, and there we have gone through with the partition value. So we will use that partition value here and we will calculate the quartile division here. So I am having the questions of the quartile division, one for the individual series or maybe one for the continuous series over there, to learn how to calculate the quartile division very easily. If some questions in examination from the quartile division, with the help of this video you can easily solve that question is over there. So I am taking two type of the question here. The first one, I will having a case of the individual series where we have to calculate the quartile division, and then we will having a case of continuous series where we will calculate the quartile division and coefficient of the quartile division. So the very first I am taking a example, that is called compare the dispersion in following two series. One series contains height given 58, then 56, then 62, then 61, then 63, then 64, then 65, then 59, then 62, 65 and 55. 62, 65 and 55. 62, 65 and 55. So height is given and weight is also given. The weight is given 117, 112, 127, 123, 125, 130, 106, 119, 121, 119, 121, 132 and 108. 132 and 108. Here we are given two series over there. We are to calculate the quartile division and having the comparison between both of the series over there. We are having the height of the 10 workers, that is 58, 56, 62, 61, 63, 64, 65, 59, 62, 65 and 55. And the weight of the 10 workers is also given, that is 117, 112, 127, 123, 125 as on. So here the serial number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the data for the 11 workers is given. Okay. So the very first we will arrange this data either in ascending order or either in descending order. So I am arranging these data in ascending order. So height, data of height. So the very small item is 55. Okay. The very small item is 55. 55, then 56, then 58, then 59, then 61 is available, 62 is also available, 63, 64, 65, 62 againly available, 63, 64, 65 two times available, this and this. Weight, the very small weight is 106. Okay, that is 106. Then 108, 106 completed, 108, second one, 108, then 112, 112, then 117, then 119, then 121, then 123, 125, 127, 130 and 132. What we have done? We have arranged the data in ascending order of both of the series. Okay. So the very first what we have done? We have arranged the data in ascending order. You can arrange in descending order also, no problem at all. For first, for height, Q1 is equal to size of n plus 1 upon 2th item value, n plus 1 upon 4th item value is over there. So the Q1 is equal to 11 plus 1 upon 4th item, that is 12 upon 4th is equal to 3rd item. So the value of Q1 is 3rd item, that is 58. It's very easy. What we will do? The very first we will calculate Q1 plus Q1 is equal to n plus 1 divided by 4. So that is 12 plus 1 divided by 4, that is 12 upon 4, that is 3. For calculating Q3, that is size of 3 n plus 1 upon 4th item value. So that is size of 3 multiplied 12th upon 4th item value. 3, 11 plus 1 upon 4th item. Of Q3, we have used the size of 3 n plus 1 upon 4th item. So here there will be 3 multiplied 12 upon 4th item, that will be 9th item. So the value of Q3 will be, the 9th item is 64, so the value of Q3 is equal to 64. Then quartile deviation for the first item, that is Q3 minus Q1 upon 2, that is 64 minus 58 divided by 2, that is 6 by 2, that is 3. So the first quartile deviation will be, the value of first quartile deviation will be having 3, because the first one is 64, second one is 58. So 64 minus 58 divided by 2, so the value of 6, and coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1, is equal to 64 minus 58 upon 64 plus 58. 6 divided 64 plus 58, that is 112. So 6 divided 112, that is 0.0537. So the value will be 0.0537. 64 minus 58 divided by 64, 122. So 6 divided 122, that is 0.049. 0.049. Or in percentage form, Q3 minus Q1 upon Q3 plus Q1 multiply by 100. So that will be 64 minus 58. That may be include or not. So it's a problem whether it may be include or not. So I am writing here in percentage form, Q3 minus Q1 upon Q3 plus Q1 multiply by 100. So 64 minus 58 upon 64 plus 58 multiply by 100. So that will be 4.9%. So we have calculated the quartile deviation between the height. These are the height data. Now we will calculate. So for the height 4.9%. So we are writing here for height, that is 0.049 or 4.9%. Okay. Now we will calculate for the weight. We will calculate the quartile deviation for the weight. Next we are having quartile deviation for weight. So Q1 is equal to size of n plus 1 upon 4th item value. So the value of Q1 is equal to size of 11 plus 1 upon 4th item, that is 3rd item. So 3rd item is 112. So the value of Q1 is equal to 112. Similarly, Q3 is equal to size of 3 n plus 1 upon 4th item value, that is size of 3 multiply 11 plus 1 upon 4th, that is 3 multiply 3, that is 9th item. So the 9th item is 127. Here first one 64, 58. So value of Q3 is equal to 127. So quartile deviation, the value of quartile deviation is equal to Q3 minus Q1 divided by 2, 127 minus 112 divided by 2. So 127 minus 112, that is 15 divided by 2, 7.5. Coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1. 127 minus 112 upon 127 plus 112, that is 15 upon 239, that is 0.062. In percentage form, Q3 minus Q1 upon Q3 plus Q1 multiplied by 100. So 15 upon 239 multiplied by 100. So 0, that will be 6.2%. So as far as the variation is concerned, for weight 0.062 or 6.2%. So we will say there is a more variation in weight than height, because in height the variation is 4.9%, but in the weight the variation is 6.2%. So we will say there is a more variation in the weightage over there. So if you are getting a case of individual series, you can solve this problem like this, whatever I have done. So the quartile calculation of the quartile deviation is not quite difficult. You can easily solve the quartile deviation. If a case of continuous series is over there, I have taken another one question, that is center size. Center size is given from 1 to 10. Frequency is given 2, 9, 11, 14. 2, 9, 11, 14, 20, 24, 20, 16, 5, 2. We are given two items. We are given the value of center size. It means center size, it means L1 plus L2 divided by 2 is given, and the frequency is given. So the very first we will calculate the class interval. So the difference is 1 to minus and plus difference by 2, that is 0.5 to 0.1. 1 is the medium of 0.5. The value of center size will be 0.5 to 1.5. Then 1.5 to, we are subtracting minus and plus 1 by 2 minus and plus 0.5. So subtracting 0.5, 0.5, adding 0.5, subtracting 0.5, adding 0.5, 2.5. This is 2.5 to 3.5, 3.5 to 4.5, subtracting 4.5, adding 5.5, then 6.5 to 7.5, 7.5 to 8.5, 8.5 to 9.5, and 9.5 to 10.5, and last one 10.5 to 11. That may be 0, 1, 2, 3, this, 2, 4, 2, 4, 3, 4, 4, 4, 5. Here we have lost 1, 1, 5.5 to 6.5. This is 6.5 to 7.5, 7.5 to 8.5, 8.5 to 9.5, and last one 9.5 to 10.5. Here the frequency is 2, 9, 11, then 14, then 20, then 24, then 20, then 16, then 5, and then 2. So the very first, what we have done, from center size we have calculated the class interval is over there. For that, the very first we will see the difference between the center size. We will divide difference. There is a difference of 1 divided by 2. So 0.5. In very first we will subtract 0.5 and add 0.5. Then subtract 0.5 to 8, 0.5. Now we require cumulative frequency, that is 2, 11, 22. 22 plus 14, that is 36, plus 20, that is 56, plus 24, that is 80, then 100, then 116, then 116, then 121, then 123. Okay. Now the very first Q1 is equal to size of n by 4th item value. In continuous series, we have to use n by 4. If discrete series is, if individual or discrete series is over there, we will use n plus 1 by 4, but its continuous series is over there. Because continuous series we want between the center is over there, that's why we are using n by 4. So n by 4 is equal to 123 divided by 4th item value. So the very first 123 divided by 4, that is 30.75. So very first 30.75 come here. In this CF we will say where the 30.75 firstly include. So this will be our frequency, this will we C, and this will be having the Q1 value. So the Q1 is equal to L1 plus I upon F n by 4 minus C, that is the formula for the Q1. And L1 is the lower limit of the Q1, that is 3.5. I the class interval, that is 1, 4.5. Difference between 4.5 to 3.5, that is 1, divided by frequency, that is 14. Here 30.75 already we have calculated the n by 4 value, that is 30.75, and the pre-cumulative frequency from this class interval, that is 22. So the value of Q1, that is 3.5 plus 8.75 divided by 14. So 8.75 divided by 14 plus 3.5, that is 4.125. The value of this is equal to 4.125. So Q1 is equal to 4.125. Now we will calculate value of Q3, that is the size of 3n by 4th item value. That is 3 multiply 123 upon 4th item. That is 30.75 multiply 3. That is 92.25. The value will be 92.25. In 92.25, we will see cumulative frequency where it 8, that is here. So the class interval of Q3 is equal to 6.5 to 7.5. Value of Q3 is equal to L1 plus I upon F 3n upon 4 minus C. So this is the class interval, this will be the frequency, this will be the pre-cumulative frequency. So we will having 6.5 plus difference is 1 divided by frequency 20. The value of 3n upon 4 is equal to 92.25 minus pre-cumulative frequency, that is 80. So this will be 6.5 plus 1 by 20 multiplied 12.25. So 12.25 divided by 20, that is 0.6125. 6.5 plus 0.6125. So adding 6.5 in here, 7.1125. The value will be 7.1125. This will be the value 7.1125. So quartile deviation, value of quartile deviation is equal to Q3 minus Q1 upon 2. That is 7.1125 minus this is Q3 minus 4.125 divided by 2. So we will detect minus 4.125, that is equal to 2.9875. 2.9875 divided by 2. that is 1.49375. 1.49375. Next we are to calculate the coefficient of quartile division, that is Q3 minus Q1 upon Q3 plus Q1, that is 7.1125 minus 4.125 upon 7.1125 plus 4.125. So the value of this 2.975, 2.9675, 2.9875 is okay. 2.9875 divided by, we will add 7.1125 plus 4.125, that is 11.2375. So the value will be 2.9875, the value will be 0.266. 0.266. In percentage, Q3 minus Q1 upon Q3 plus Q1 multiply by 100. So 7.1125 minus 4.125 upon 7.1125 plus 4.125 multiply by 100, there will be having 26.6. 2.9875 divided 11.2375, that is 0.2658. 2658, or having 26.58%. So from this method we can calculate quartile division is over there, coefficient of quartile division is over there. If we are to having the comparison between the two series, seeing if they are asking in which series the dispersion is high, so we will see the percentage or the value of quartile division. Where the value of quartile division will be higher, there will be more dispersion. Where the value of quartile division is lower, there will be less variation or less dispersion is over there. So I think from this video you may be now what is quartile division, how to calculate the quartile division, and how we can compare two series with the help of the quartile division. I think this video will be helpful for you. If you are feeling any kind of the problem, you can having the comment in the comment box, and I will try my best to reply you if you are feeling any kind of the problem in calculating the quartile division. Thank you.